Hi guys, and welcome to your lesson on what we call indefinite integrals. And this is going to be the exact same idea that we explored with the primitive function, just that the functions may start getting a bit more complex to work with. So if you keep in mind that the big picture about integration or the antiderivative is finding the area under the curve, with these ones we have no boundaries set into which we're finding areas. We're just looking for the actual integrated function. So for these questions, it's really important that we consider that there could be a constant at the end of the function. Okay, so now on to example number 1. In this question, we're asked to integrate x to the power of 4 minus 3x squared plus 4x minus 7. Okay, and if we've forgotten just about doing that primitive function, remember the first thing we're doing is we're adding 1 to that power of the thing we're differentiating, then we're going to divide that part of the function by that new power. Okay, so let's go and do question number 1. All right, so we're going to write our function part out. We're going to add 1 to that power and divide by the new power. Same goes, writing the function part out. That becomes a 3 divided by 3. Okay. Then we get to this part and we say, all right, we've got to do a plus c. There could be another value there, a constant, that would get absorbed if we were going to differentiate and go the other direction. And as always, let's just tidy this part up because we've got one part that tidies up really nicely, which is this part here. And also this becomes 2x squared. All right, to write our answer out nice and neatly. So if it was a definite integral and we were actually looking for areas on the curve, that's when we'd go now and substitute this function between those two definitions. Okay, example number 2, we're integrating 5x to the power of 9. Okay, so these same principles apply to the last question. If we're going to integrate this one, we're going to write the function out, add one new one to the power, don't forget the plus c. Okay, so this is going to simplify again quite nicely. So we're going to get ourselves x to the power of 10 over 2 plus c as our final answer. Okay, example number 3, and there's a lot going on in this question. It seems like it's going to be a much more difficult one. But just like when we're doing our normal calculus, sometimes things look a lot harder than they seem. Now in this case, we can do something first before we start to integrate. That'll help us greatly. That's right, we can take a common factor of x out of this top part of the equation because we've got x's all round, and that's going to end up giving us a cancelling of that bottom part, so it'll look just like question number 1. Okay, so there we go, common factor of x out of the top, and now we can cancel that. So really we're going to be integrating 2x to the power of 4 plus 7x minus 3 with respect to x. So let's go and apply that principle, which says write that first part of the function, add 1 to your power, divide by the new power. And keep on going through, and don't forget the plus c. And this one we can't really tidy up, so we're done. So the keys for this question were really thinking about some other algebraic techniques you could use to simplify that expression before you went to start integrating. Okay, example number 4. And again, there's a lot going on initially with this question, but if we think about a few things, we'll be able to then go and work with this in a bit of a nicer way. So who can think of what to do? Yeah, we're going to have to rewrite this using negative indices and then fractional indices. All right, so really what we're doing, we've got x to the power of negative 3 plus x to the power of a half that we're going to try and integrate. Okay, so this first part, remember, we write the function out. Now this is where it's again a tiny bit different. We're at minus 3, we've got to add 1 to the powers, so really we're going back to minus 2, divide by that new power. So same general ideas apply, just it's a real temptation for you to go minus 4 there for the power. All right, so we've got to be stayed switched on for that one. Again, this one here, we've got to add 1 to the power, so it's going to be 3 on 2, and then divide by that new power, all right, plus c. Okay, so tidying up, we want to first of all get rid of that negative power. So we're going to have 1 on negative 2x squared. Okay, so we've turned this negative power back into a positive 1. Now for this next part, don't have negative powers this time, but we've got those fractional indices. So that fractional index is going to be square root of x cubed. And then we've got this dividing by 3 on 2, so we're going to flip reciprocal and multiply. So it's going to be 2 root x to the power of 3 on 3. And don't forget your plus c. All right, now I'm going to focus in on this part for a second here just to make sure. Remember, this question has said we're getting this and we're dividing it by 3 on 2. All right, and I'm always going through this with my class, I know. So it's x to the power of 3 on 2 times 2 on 3. All right, and we can even write that on 1, and we're just going to multiply across the top and across the bottom. So it's 2x to the power of 3 on 2 over 3. And all I've gone and done is change this fractional index into square root. So again, just like the example before, a few algebraic techniques you've got to consider or be switched on to while you're trying to do these antiderivative or integration style questions as well. All right, so good luck with your homework exercises for this. Okay, keep in the back of your mind some of those algebraic techniques, because when the questions look a bit more complex, there's probably something you can do to work around it.